G'day problem solvers. Today we are going to be looking at some patterning in algebra. This stuff has mainly come from the Thinking Math workshop ran by the Department of Education that Mr. Murray and I went on last year. Special thanks to them, Maureen, Pauline and Elise, who provided us with these resources and kind of went through this stuff with us. All right, so our key tasks, so these are kind of like our learning intentions. So our learning intentions for you guys is recognize and identify and extend a pattern, create a pattern or supply a missing part, to analyze and describe the pattern, to apply what you've learned about the pattern to generate new knowledge. So that's what we're going to go for with our tasks today. Okay, so looking at this pattern in front of us, it's called repeated patterns. What might be the 10th element in the pattern be? So having a quick thing, it says element. What might element mean in this? Maybe discuss with the next person or the person next to you about what element means. And hopefully you can work something out. So once you've done that, have a think about what the 10th one or what the 10th element might be and why. All right, have a think about that now. Probably pause me. Okay, so then the question is, can you generalize, if I can talk properly, can you generalize? What does generalize mean? Have a conversation with the person next to you and see if you can work that out. Okay, so and we're back. So hopefully you spoke about element. When we're talking about element, the 10th thing in the pattern. All right, and when you're talking about generalizing, you're talking about coming up with an idea or a rule or some words about, the bell's going, how this would be the case for the whole time. So can you come up with a rule around that and write that down? All right, so pause me to write down your answers. Okay, linear patterns. Can you identify some of the different quantities that are varying in the pattern? So what do we mean by quantities? Quantities means amounts. So if we look at our patterns down there, it has first term, second term, third term. Now, obviously, we're not talking about terms as in first term of school, second term of school. We're talking about first section of the pattern. So in our previous one, each section of the pattern was a single shape, wasn't it? Well, in this one, we have yellow hexagons in the pattern no matter what. We identify them by the space and the word term. So that's our first term there. That's our second term. That is our third term. So what are some different ways or different amounts that we could add up or that we could attribute, we could name each of these shapes? Pause me and have a think about that for a second. Write down your answers. Okay, now what I want you to do is create the shapes or create the pattern using actual blocks. So use the pattern blocks to create a linear pattern and investigate its perimeter. So perimeter, remember, we're looking at around the outside of the shape. So I want you to physically create those with your shapes. Once you've done that, come back on. So looking at it, you need to copy the pattern, extend it, record the perimeter if a side is 1 unit. So from there to there is 1 unit. Obviously it's a certain amount of centimeters or millimeters, but we're just going to use that as one side, so we'll call that 1. Okay, so that's 1, 2 down there. Right, make a T-chart. So I'd like you to make a T-chart. Okay, so I've just made a T-chart quickly here and put it down the bottom. So you can see term and sides. So each term, as we talked about, term 1, term 2, term 3, I count the amount of units on the side. So my first is 6. What would be my amount of sides on my second term? Then my amount of sides on my third term. Okay, so I want you to keep going, and then can you find the perimeter for 10 hexagons? So you might want to do your chart here for down to 10, and as you're going along you may or may not pick up a pattern. But then you need to go to 100 hexagons. I wouldn't suggest you do a T-chart down to 100 hexagons. I want you to think about how you could do a shortcut. So can you just jump to 100 hexagons somehow? All right, so I want you to think about that and think about perhaps some different ways of getting to that 100 mark as well. So yes, one would be doing this T-chart and going 1 down to 100. All right, that's one. I don't want you to do that, but I want you to try to think of some other ways that you could do it as well, and then also give me the answer to that. So once you've done that, the last step I want you to do is for you to write down in words one of those ways where you could work out that 10 hexagon, that 100 hexagon without having the shapes there, without bringing them up, drawing them out, or using your counters and counting the sides, without going through your T-chart and doing what you did each time to work that out. Could you just come up with a way or a formula or a rule that kind of, if I said in a unit, or in your 34th term, how many sides would it have? Would you be able to tell me that? So what rule would you use? What strategy would you use? Finish that off. Then we'll get together as a whole group to have a discussion about that. And just finish it all off, and then go to the next step. So good luck, guys. A little bit of work there, so hopefully you've worked through and you come up with some really good thinking and ideas. Cheers.